This video is for Algebra 1, Chapter 2, Lesson 1. Today's quote comes from Horseradish by Lemony Snicket, Bitter Truths You Can't Avoid, page 73. It is much, much worse to receive bad news through the written word than somebody simply telling you, and I'm sure you understand why. When somebody simply tells you bad news, you hear it once and that's the end of it. But when bad news is written down, whether in a letter or a newspaper or on your arm in felt-tip pen, each time you read it, you feel as if you're receiving the news again and again. Which is why you should not break up using text messages, okay? All right? Okay. All right, so on to math. We're going to be talking about solving two-step equations. Property of equality. What you do to one side of the equation, of the equal sign, you must do to the other side. You have to keep things equal. So it's like passing out apples. If I'm going to pass out 2 apples to the right side of the equal sign, I need to pass out 2 apples to the left side of the equal sign. All right? Now the whole objective for today is to get the variable by itself. We're trying to figure out what the variable is. So to do that, we have to undo what's happening to it. So for the first problem here, we have 7 equals 2y minus 3. So if I'm going to get the variable by itself, I have to undo it, undo what's happening to it. I need to undo the multiply 2, and I need to undo the subtract 3. The thing is that when I'm solving equations, I have to take care of lower priority operations first. Sorry, Miss Michelle just walked in. So again, when we're solving an equation, we have to do lower priority operations first. Lower priority operations are addition and subtraction. The higher priority operations are multiplication and division. So we take care of lower priority things first. So that's why I'm going to add 3 here and add 3 here. I'm going to add 3 on both sides because what I do to one side, I have to do to the other. Since I'm undoing and minus 3, I'm going to add 3. Negative 3 plus 3 is 0. But again, since I needed to get 0 on the right side here, what I did to this side to get 0 on the right, I have to do on the left side. So 7 plus 3 is 10. And since this negative 3 or minus 3 plus 0, or plus 3 is 0, I've just got the 2y left over. All right, so now that I've simplified this down to 10 equals 2y, I can now take care of the higher priority operations, which in this case is multiplication. So I'm now going to divide by 2. So the opposite of multiplication is division, since I have to, because that's going to get rid of it, because what's 2 over 2? 2 over 2 is 1, so that cancels out. So, but what I do on the right side, I have to do on the left side. So now I've got 10 divided by 2. Well, 10 divided by 2 is 5, and there's nothing left on the right side now except for y. So y equals 5. And what I can do is then I can go plug in y, 5 for y, and see if it works. So if I make this a 5, I've got 2 times 5. Well, 2 times 5 is 10. 10 minus 3 is 7. So it works. It gives me a true statement. All right. Let's go ahead and move on to the next example. We have x divided by 9 minus 15 equals 12. So I got to take care of the lower priority operations first. That would be the minus 15. And you guys can always add the opposite, because adding the opposite will get you that true statement that you need to, so that you could figure out what the opposite of what's going on is. So if I have minus 15, the opposite of 15, or if I have plus negative 15, the opposite of that would be plus 15. So I'm going to add 15 on both sides. Negative 15 plus 15 is 0, so that's now officially gone. And we have x over 9 is equal to 12 plus 15. 12 plus 15 is 27. So now that I have 27, I'm going to go ahead and undo this division. Because remember, when you have the fraction bar, it means division. So the opposite of dividing by 9 is multiplying by 9. So if I multiply this side by 9, I'm going to end up with 9 over 9. Well, 9 over 9 is 1. But again, what I did on this side, I have to do on this side. So if I multiplied by 9, I now have to do 27 times 9, which is kind of nasty. And that's my calculator, you hear? Because you can use a calculator. So x is equal to 243. So let's go ahead and check that. If we have 243 as x, 243, and we divide that by 9, you're going to get 27. 27 plus negative 15 is going to give you 12. Okay, so there you go. And it's always good to double check your work just to make sure that the equation works. All right, so word problem. You order tulip bulbs. You have $14 to spend. If the bulbs cost 75 cents each and it costs $3 for shipping, how many bulbs can you purchase? So, and ship. Got to purchase it and have it shipped to you since you're ordering them online or through a catalog. Okay, so if I know that it's 75 cents per bulb, I'm going to make B the number of bulbs I'm going to buy. So if I bought 3 bulbs, it would be 3 times 75. But I know that I need to include shipping. Shipping is a constant here. It's just one-time fee. I don't have to multiply anything by it because I'm only going to have it shipped once. Unless I make a second order, but maybe I have more than $14, so it's a whole different situation. But I know that I can't spend more than $14. Maybe I can spend exactly $14. All right, so I'm going to go ahead and solve this problem. I'm going to subtract 3 on both sides because I take care of the lower order operations first. So 14 of my dollars is going to be spent on shipping. All right, if 14 of my dollars is spent on shipping, that means that I have $11 to spend on bulbs, right? Well, if I have $11 to spend on bulbs and I divide that by the cost of 1 bulb, it's going to tell me how many total bulbs I can buy. So 11 divided by 0.75 is 14.666667, okay? So 14.6 repeating, basically. The only thing is this catalog is probably not going to sell me 0.6 of a bulb. So more than likely, I can only buy 14 bulbs, not purchase 14 bulbs. Okay, 14 bulbs. Alrighty, next page. All right, so this is when you've got a negative variable. Negative variables are a lot easier than they sound. You just need to remember that they're the opposite of the actual number. So let's go ahead and solve them. And actually, they're really easy in the 2-step because you're just either multiplying or dividing by a -1 to get the variable by itself so that the negative is not there. So again, I'm going to take care of lower priority operations. So I'm going to minus 7. We've got negative x is equal to 5 because 12 minus 7 is 5. And so to get rid of the negative in front of the x, and we have to do it because the variable really doesn't want to be its opposite. It wants to be who it is. So to get rid of it, we're either going to multiply by -1. So multiplying by -1 makes it the opposite of what it is, which is just x. And 5 times -1 is -5. Misty-H, -5. There we go. And you can plug it back into C. So if I have the opposite of -5 plus 7, I need to see if this is a true statement. Not 12, 2, 12. There we go. Okay, well, so what's the opposite of -5? Well, the opposite of -5 is 5. 5 plus 7 is 12. So that is a true statement. So this works. All right. Next problem. And actually, I might skip number 4 because number 4 is not that big of a deal. The thing is, though, is that I am going to add the opposite for number 2. So I have, this is a -a, by the way. It kind of looks like a funky cursive O, but it's a -a. There's a negative sign. There's a negative sign. Okay? So I'm going to add the opposite, which turns this into -a plus -5 equals -8. So now I'm going to do the opposite. Well, what's the opposite of adding -5? Well, that would be adding 5, because the opposite of -5 is 5. But what I do to one side, I have to do to the other. So -a is equal to -3. And then remember how I multiplied by -1 here? Well, you can also divide by -1, and it's going to do the exact same thing. Negative divided by a negative is a positive, so I'm left with a on the left, and a negative divided by a negative is a positive. -3 divided by -1 is +3. And again, you can plug it back in to double check, and you're going to end up with -3 plus -5 is -8, which, hey, that's a true statement. Check that out. All right, I'm going to skip number 3. If you want to do it, you can do it, and you can check your work with me, but I'm going to skip it because there's one more thing we got to talk about, and that is deductive reasoning. So deductive reasoning basically is just justifying your steps. So whenever they say justify your steps in the textbook, it means they want you to tell which properties were used to simplify the problem, okay? So what I'm going to do first for number 1 is add the opposite, and so that is actually either called the definition of subtraction, or you can just call it adding the opposite. All right, both of those I would accept on any test you gave me, okay? All right, now that I've added the opposite, I'm going to take care of lower priority. So I'm going to add 9 on both sides, add 9 on both sides, and this is what we call the addition property of equality. So let's see here, addition prop of equality. All right, and you can abbreviate it. I'm not too big of a stickler, but you still have to be able to, identify these things. So now that I've added 9 on both sides, this cancels out, and I have negative 4m equals 12. So now I'm going to divide by negative 4 because it's being multiplied up here, so dividing would be the opposite, and this would be the multiplication property of equality. Right? There we go. So if I've divided by negative 4 over negative 4 is 1, which just leaves m is equal to negative 3. And there you go. All right? So I'm not even going to bother doing number 2 because this video's gone on long enough. Just make sure you can identify stuff. If you did the same thing on one side as you did the other, it's just that operation, property of equality, addition, property of equality, multiplication, property of equality, division, property of equality. All right? Bye.